Okay. So my name is Paul. This is work that I started at Queen's University, and Nick Fellion and Jesse Burstyn ended up turning into a paper, supervised by Roberto. So at the Human Media Lab, where this work was done, a lot of the research focuses around interacting with non-flat computers. A non-flat object that you might want to interact with is a sphere. And we do a lot of physical prototypes, and in prototyping, we're often faced with a problem similar to that of map makers. You have something round, and then you look out, okay, what sensors can you buy? And they're usually flat. And you have this problem that you only can ever get an approximation of the shape you actually want if you're working with flat sensors on a non-flat surface. Because of this problem, we sort of have a history of building our own sensors. This year, our sensors built by David Holman. He presented them at DIS. These are resistive sensors. And we sort of had a series of these sensors coming out. And also other labs have researched these sort of ad hoc special purpose sensors. This is a project called Midas, which was from Berkeley. I think it was 2011. And the reason why I chose this picture is you see on the left-hand side, there's a two-dimensional sensor, which is then wrapped around the three-dimensional object. So I really like this work. This is really cool work. But even with this, you're still stuck with sort of this fundamental disconnect of you're designing an object and you're designing its shape and form. And on the other hand, you have the sensing solution. And at some point, your sensors and your objects get combined. And one of the design philosophies, or something that I believe in designing tangible objects, is that the interaction, it's in the shape and in the physical material properties of the object. So adding the sensors later on in the process is sort of feels disconnected. So the reason we started playing with 3D printed sensors is we thought maybe we could have a single workflow in which we create sensors and the object at the same time. I'd like to talk about sensing for a moment, because I think conceptually we often think sensors are way more complex than they actually are. I'm just going to show a couple of sensors I can build just using some coins and using pull-down resistor and measuring voltage. So a real simple sensor I can build is a touch sensor. So you've all probably built these. If I want something more complex, I can, using exactly the same circuit, I can turn it into a switch. Okay, so now I have a switch. Again, you're probably not very impressed because you've built these before. But there's a lot of stuff that you can do simply by manipulating the configuration of the material and how you interpret the data. So for example, the same configuration could be a pressure sensor. So the harder I push, you see this line moving. And some of you might have played with sensors and know that actually this is almost a galvanic skin response sensor. So I can do this. I can build a simple lie detector. I'm talking right now, so I'm worried I'm sweating, so I'm drying off my fingertip. And again, I'm touching my coins, and I'm not lying to you. But if I make my finger wet. So all of these, the point I'm trying to make is that simply with measuring voltage and having conductive materials, by configuring them in different ways, you can build all kinds of different types of sensors. And that's where 3D printed materials become really interesting, because there's conductive 3D printed filament, and now I can actually arrange the material programmatically in any shape I want. So this allows us to do exciting things. I'm just going to show you one example. Here's a slider, which I built using the same method I just showed you for the galvanic skin response and the pressure sensing. And I can do multi-touch. And this is relatively coarse. Like you see, I have, I guess it's 7 probes, but using interpolation, you can actually, in theory, you can get very high resolution signals out of these sensors. this conductive material, not only can I configure it in any shape I want, it's also it's flexible, and that allows you to do other cool things. Now what I'm going to try to do, it never works the first time, so just bear with me. So what I'm showing you here is a flex sensor, and because I'm just doing this on the fly, I'll have to do some calibration here. Okay, so now it's not bent, and if I bend it, you see I get a signal out of it. And what I'm doing is I'm physically stretching the conductive material, changing its conductivity by doing so. So you might say that, again, I'm just building sensors, which you would now add to other objects. And that's because I really love measuring things and building sensors, and that's sort of what I do. But others took over from here, and so this is work done primarily by Jesse. He wrote the scripts in Rhino. So here you have a screenshot of his Rhino software, and he created a cone, and he drew 4 points where he wants sensors to appear. And then he runs a script which, from this point, finds the closest surface in the 3D model and projects a sensor onto it and creates that sensor. And in the next step, he creates outputs where he wants his crocodile clips to connect, and again runs a script connecting these sensors with the outputs. So here you have a workflow where you're creating the shape of the object and where you want to position interactivity at the same time in one single process. And then you send it to a printer and you build your objects. So the demo I showed you is just a flat object. I showed it to you because this is the one I happen to have with me. But obviously they don't have to be flat. That's the whole point why we're doing it, to explore non-flat shapes. And they can actually be two-dimensional, or in this case, actually sort of three-dimensional. So this is a two-dimensional touch screen wrapped around a three-dimensional surface, which can measure 25 points and interpolate between them. Or you can create completely abstract or shapes which you can't, or you can, but normally would not describe with this type of vocabulary. And this is really where we want to get to with this project, where we're just printing any shape we want and in the workflow are integrating the sensors to it. And I'm just gonna have a video running in the background now, and I'm happy to take questions. So because I sort of been browsing over the technical details, if you want more technical details, you can talk to me afterwards or ask a question now. Thank you. So I just commented. The black material is conductive, and this is a MakerBot using a dual print extrusion. And the way we're measuring all points is we're basically using this here as a multiplexer. So we're first sampling the rows and then we're sampling the columns. Again, using the same method I just showed you that I used for pressure and galvanic skin response with the coins.